The heavy metals era, 1940–1970. We begin in an age of brute force. From the 1940s through the late 60s, the goal was simple: make it rain or hide from radar. In 1943, the military introduced chaff, primitive strips of aluminum foil and metallized paper. It was effective but heavy. By the 1950s, scientists moved to Project Cirrus, dropping dry ice and silver iodide. 1950s, 1960s. Transition to glass dipole fibers. These consisted of a fiberglass core coated with a thin layer of aluminum. These fibers were designed to be incredibly light, so they could remain suspended in the air for hours to study atmospheric drift and disrupt signals. Late 1960s. Use of lead, iodide, and silver. Iodide often dispersed via pyrotechnic flares, which produced distinct, colored smoke plumes, often orange or yellow, to allow visual tracking of the dispersal patterns during experiments like Project Popeye. The Transition Era. Polymer and Tracer Fibers, 1980s, 2000s. The focus shifted toward environmental modeling and more sophisticated tracking methods, 1980s. Experimental use of polymer-coated fibers. These were used as tracers in atmospheric studies. By using different chemical coatings, researchers could distinguish between different spray events when collecting samples later. 1990s. Introduction of aluminized plastic, Mylar filaments. These were thinner and more durable than previous glass-based fibers, allowing for better loitering time in the upper atmosphere. Modern climate engineering. Synthetic and nanofibers, 2010s, 2026. The current Omission by design era involves materials designed for specific light-scattering properties, 2010s, development of piezoelectric fibers and smart dust, research into fibers that could respond to electromagnetic frequencies to alter their orientation in the sky. 2020–2026, implementation of synthetic, polymeric fibers and carbon fiber filaments, color fibers, small, dyed polyethylene or nylon fibers are sometimes used in localized weather modification tests to visually map the mixing of the atmosphere. Nano-Particulate, webs, specially engineered fibers that can clump or web together upon contact with atmospheric moisture, potentially used to trap other particulates or enhance cloud seeding efficiency. 2026, the era of dispersed logic. Today, in 2026, the technology has reached its final form: aerosolized electronics. We have moved past silicon into carbon nanotubes and graphene. We are no longer carving chips. We are growing them at a molecular level. Narrator. Current atmospheric loads consist of nanotransistors, invisible logic circuits printed onto flexible polymers, synthetic polymeric fibers, microfilaments that act as antennas for electromagnetic frequencies, bio-inspired flyers, microchips shaped like seeds, designed to stay aloft for weeks without a power source, color-dyed tracers, tiny polyethylene fibers used to map atmospheric mixing, often creating the iridescent rainbow effects we see in the clouds today. The computer didn't just get smaller, it became the air itself. We aren't looking at pollution. We are looking at a programmable medium. This is the ultimate omission by design. Official atmospheric material timeline. It's 1940 to 2026. The metal and heavy particulate era. 1940 to 1975. 1940s to 1950s. Initial use of aluminum chaff, strips of foil for radar masking and dry ice. Solid CO2 for Project Cirrus. 1960s to 1970s. Tactical use of silver iodide and lead iodide. Project Popeye. Visual color code. Heavy silver and metallic gray. The Polymer and Tracer Transition. 1980 to 2010. 1980s to 1990s. Shift to aluminum-coated fiberglass and Mylar filaments. Tracer colors. Introduction of barium, blue-green, and strontium, crimson to map atmospheric drift. Visual color code. Electric cyan and vivid primary tones. The Nano-Polymer and Carbon Era, 2015 to 2026. 2015 to 2020. Implementation of alumina, aluminum oxide. For thermal reflectivity and sulfur dioxide. 2020 to 2026. Advanced use of synthetic polymeric fibers, carbon fiber filaments, and graphene. Modern colors. Use of dyed polyethylene and nylon fibers for localized mixing tests, creating rainbow clouds. Visual color code. Iridescent purple, neon glow, and matte black.